Hi, welcome everybody. Today's class is on mathematical induction. This is class number 3. In the last class, we have proved some mathematical statements using the principle of mathematical induction. Let us prove some more mathematical statements using the principle of mathematical induction. In the previous class, I have defined the step-by-step procedure to prove a mathematical statement using the principle of mathematical induction, and repeat it once more. What is step number 1? Write the statement as P of n. Step number 2, we prove that the statement is true for n equal to 1. That is, P of 1 is true. What is step number 3? We assume that the statement is true for n equal to k. That is, we assume P of k is true. What is step number 4? We prove that the statement is true for n equal to k plus 1. That is, P of k plus 1 is true. Therefore, the statement is true for all natural numbers. This is the step-by-step procedure to prove a mathematical statement by the principle of mathematical induction. Okay, let us see the mathematical statement. Here, sigma I varying from 1 up to n of I square is equal to n cube upon 3 plus n square upon 2 plus n upon 6. We are asked to prove this mathematical statement. How will you prove? What is the first step? We write the given statement as P of n. What is P of n? P of n is sigma I varying from 1 up to n of I square is equal to n cube upon 3 plus n square upon 2 plus n upon 6. Okay. Now what is the next step? We prove that the statement is true for n equal to 1. We put n equal to 1 here. Therefore, we get the statement P of 1. What is our P of 1? That is sigma 1 up to 1 of 1 square is equal to 1 upon 3 plus 1 upon 2 plus 1 upon 6. Okay. Now sigma 1 upon 1 of 1 square, that is equal to 1. And what is the term on the right hand side? That is 2 plus 3 plus 1 upon 6. That is 6 upon 6 is equal to 1. That is 1 equal to 1. The left hand side is equal to the right hand side. Okay. That means the given statement is true for n equal to 1. Now we move on to the next procedure. What is the next procedure? We assume that the statement is true for n equal to k. That is P of k. What is our P of k? Put n equal to k in the given statement. Then P of k is obtained. P of k is sigma I varying from 1 up to k of I square is equal to k cube upon 3 plus k square upon 2 plus k upon 6. Now using this statement, we prove the statement for n equal to k plus 1. That is, we are going to prove it for n equal to k plus 1, or we prove P of k plus 1 is true. Using the statement, in the statement for P of k, I am going to add k plus 1 on k plus 1 the whole square on both sides. Okay, that is sigma I varying from 1 up to k of I square plus k plus 1 the whole square is equal to k cube upon 3 plus k square upon 2 plus k upon 6 plus k plus 1 the whole square. Now I am going to simplify the right hand side. Keep the left hand side as it is. The right hand side will be 2 times k cube plus 3 times k square plus k plus 6 times k plus 1 the whole square upon 6. That is 2 times k cube plus 3 times k square plus k plus 6k square plus 12k plus 6 upon 6. Okay, it is expand k plus 1 the whole square and multiply by 6. Then you will get this expression upon 6. Now I rearrange the terms as in this way. That is, I am taking 2k cube plus 6k square plus 6k plus 2 plus 3k square plus 6k plus 3 plus k plus 1 upon 6. Okay. Now in this expression, which is the common factor? The common constant is 2. I am taking 2 outside. 2 times k cube plus 3k square plus 3k plus 1 plus in the second term here, which is the common factor. 3 is the common factor. I am taking 3 outside. 3 times k square plus 2k plus 1 plus the remaining terms is k plus 1. K plus 1 upon 6. You may verify. When you add all these things, you are getting this term. You should get 2k cube plus 3k square plus k plus 6k square plus 12k plus 6. They are rearranging this numerator in this way. Okay. Now what about the coefficient of 2 here? The coefficient of 2 is k cube plus 3k square plus 3k plus 1. That is the k plus 1 the whole cube. Okay. K plus 1 the whole cube. That is already there is a 2 here. 2 times k plus 1 the whole cube. Plus here 3 into what about this term? K square plus 2k plus 1 is k plus 1 the whole square. Plus k plus 1. Upon 6 is there. Here there is a 2. 2 upon 6 means k plus 1 the whole cube upon 3 plus here there is a 3. 3 in the numerator and there is a 6 in the denominator. That is we are having 2 in the denominator here. That is k plus 1 the whole square by 2. Then for the last term the denominator will be 6 plus k plus 1 upon 6. What does this mean? What about the left hand side? The left hand side is the summation will be from 1 up to, if we combine these two terms, the summation will be from I varies from 1 up to k plus 1 we are obtaining of I square is equal to k plus 1 the whole cube upon 3 plus k plus 1 the whole square upon 2 plus k plus 1 upon 6. That means the given mathematical statement is true for n equal to k plus 1. Therefore, it is true for all natural numbers. Okay, that is we have proved this statement sigma I varying from 1 up to n of I square is equal to n cube upon 3 plus n square upon 2 plus n upon 6. Okay, now what about the left hand side? When we expand the sigma notation, what are the terms we obtain here? That is we will be getting, when we put I is equal to 1, we will get 1 square, isn't it? When I is equal to 2, we get 2 square. When I is equal to 3, we get 3 square, plus etc. plus n square. N square is equal to, what about the right hand side? The right hand side is n cube upon 3 plus n square upon 2 plus n upon 6. Okay. That is what about the left hand side? The left hand side is the sum of squares of the first n natural numbers is equal to n cube upon 3 plus n square upon 2 plus n upon 6. This we can further simplify in another way also. See, I am writing here. That is n cube upon 3 plus n square upon 2 plus n upon 6. What is the common factor in the denominator or the LCM? That is equal to 6. Therefore, this will be simplified as 2n cube plus 3n square plus n upon 6. That is, which is the common factor? Common factor is n. You can take n outside. N into, we will be getting 2n square plus 3n plus 1 upon 6. That is equal to, how we can simplify this? N into n plus 1 into this 2n cube, 2n square plus 3n plus 1 can be factored in the form n plus 1 into 2n plus 1 whole divided by 6. That is, we can write the given mathematical statement in this way also. Prove that the sum of squares of the first n natural numbers is equal to n times n plus 1 times 2n plus 1 upon 6. Or else sigma I varying from 1 up to n of I cube is equal to n cube upon 3 plus n square upon 2 plus n upon 6. Okay, that is, we have verified the given statement by the principle of mathematical induction. You can put the values for n and verify the answer, or you can check the answer, see whether the left hand side and right hand sides are equal. That you may do it for yourself. Today we will stop the class. Thank you.